in AutoCAD, and after that we will export to the Graitec and convert for the hole, okay, for the circular hole or opening we will use in the DS file and convert it to the AutoCAD. You see here, this one is the circle, we draw circle, then we convert directly in the GAD, and this one is the OSF, we will draw polyline, close polyline, and after that we will convert it into opening in GAD. Now let's start from the top view. Open the drawing. Okay, our drawing is in method. In method the unit in drawing. So let's start copy, and now we need for this framework. Okay, I copy it. CO, copy to other side. Okay, this is the same for the bottom, and this is for the top. It has no opening at the top. Okay, and our bottom is the same, but we have opening in the wall. Okay, on the wall in 3 sides. Now let's copy this side. CO, okay, copy to this one, and after that we have to draw polyline for the slab. Okay, for bottom slab and top slab is the same. Now PL, enter, and shift and right click mid between 2 points. Click 1 point, 2 point, mid between 2 point, 1 point, 2 point. Again, shift mid between 2 point, 1 point or 2 point for draw polyline, or you can do other option. In this case, we can offset. You can offset if the signal of wall is the same, but in the case signal of wall is not the same. See, in this side is 25 centimeter, this side is 25 centimeter, and this side is 30 centimeter. So you have to draw polyline. Okay, now continue to PL again. Click, see, middle point, click, and click. Now let's join this line together. G, enter. Okay, we have complete for the top and for the bottom slab. Copy, we model in the middle. Okay, at the edge or the center line of the element, and pass this one for the top and for the bottom slab. And now for this one we use for the wall. Okay, again PL, enter, right click, select middle point, 1, 2, again 1, 2, again 2 point, 1, 2, again 1, 2, C, enter, close. Okay, and this one we has a circle. You can check the diameter circle in the framework. Diameter circle is 1.4 meter. Okay, now you can draw it. You can check it. Okay, draw it. It's enter where we enter for vertical, and it's enter horizontal, C, enter, and tidy for diameter, and 1.4. Okay, this is the diameter and location of the other pie. Now you click the boundary for the wall and boundary for the opening. Okay, again, now we let move it to outside. Okay, and this one for the OVH shape we use the same concept. Okay, we use the same concept. Now let's draw PL enter. See, right click on mouse and click on the middle 2 point. Okay, again middle 2 point, and you can use offset or you can use other option as you want. Okay, again select mid 2 point and see enter. Okay, for the OVH shape you cannot use direct drawing from the architectural model or from the owner, so you have to draw polyline. Now OE enter, and you have to draw polyline. Okay, this one you have to draw polyline. Oh, sorry. Now I delete this dimension and PA enter. Click, draw it as polyline. Don't use as or other shape because it doesn't support in GAD. Now just click and click. Okay, enter. Finish. And after that you click for the boundary of wall and boundary of opening for over it. Okay, and move it to outside. Press SH. Okay, now we complete for the over it, and this one we complete for this side. Okay, and for another side you can do the same for the circle opening. You can check here, this one dimension is DLI enter. DLI enter. You can check here, the dimension is 2.6. Okay, now let's check where is 2.6. This one. Okay, 2.59. so this is the opening for this side. Okay, this side. Okay, 2.1. so you need another opening for this side. Now let's check DLI enter. DLI enter. Click from the side into the outside is 3.658. Okay, now come back again and we use this the wall. Okay, now it's we enter. Okay, now it's the same. Now it's the same. Is section AA. Okay, section AA. So you cut see this pie. So now we need to use for this pie. So we use from all it. It's the same dimension for wall. Okay, CO enter. Okay, copy and check for the location of pie. Click from middle side. Okay, check from the middle side or this wall, DLI enter, click and check at the center is 1.1. okay, now let offset from this side to 1.1 is enter, we enter offset 1.1. okay, sorry, we delete it, offset 1.1. okay, and for the we do the same. okay, you can check for the elevation is 37.2 and elevation for the O it is the same, is 37.2, so the elevation is the same. Now we copy it, click, sorry, we have to copy it again, copy this hole, okay, the opening and path. okay, now complete. We have four side, okay. Now let's prepare it. This is for the top, this is for the top, and now we call it left, and for the front and for the right. okay, so now we take the left, move to the location left, this one front and this one the right. okay, okay, now copy, create other new AutoCAD, and enter, change the scale to meter. Again, let's check again, and enter, okay, the scale in meter, OP enter, change to the meter, okay, change to the meter, okay, and copy and paste. okay, now this one for the top and bottom slab, this one for the left, for the front and for the right. okay, now let's seal it to the DSS file, and I call it design manhole. okay, after you seal to DSS file, close it and close the original file. Now let's continue. When you complete modeling for the bottom and the top slab, for the front wall we call it front wall, okay, and this is the left wall, okay, and this is for the right wall, we call it right wall, left wall. So in the left wall we has a OVS shape. Now OVS shape actually this shape like this one, but we can use ellipse. Now I'm a ellipse. You can check for property here, ellipse. So you can model it as ellipse in this model. After you complete modeling for the top and bottom slab for the wall, and you can check for any area dimension, and now it's correct, and you can create another new AutoCAD file and set up unit to meter, and set up OP unit in the meter the same. And after that you can seal it as to the manhole design in GAD. okay, you can seal it as to the DSS file, okay, the file and manhole GAD, because I have default already. Now let close AutoCAD. After that close all AutoCAD and open file GAD, Graitec Advance Design, Graitec Advance Design, and you can design and click on project setting. You can save it. Okay, manhole design in GAD. Okay, and you can save it as to manhole. Okay, now I call it manhole design in GAD and save. And after that you click on the file, import DSS. We import the file from AutoCAD and manhole. Click OK, and the unit we draw in AutoCAD in method. We import type, import 4 line. Okay, now let's check. This one for the top and the bottom step. This one for the left wall, we call it left wall, we call it front wall, and we call it right wall. And the thickness of the top and the bottom is 30. The thickness of the left and right side is 30, and the thickness front wall is 25 centimeter. Okay, now let's convert this one by clicking on opportunity, convert to the planar element. Okay, you want to keep line or you want to delete line. Okay, now I want to delete line. Okay, so again you can click on no. Okay, in the case is error, you can convert it by using line. You can draw it. Okay, now I let draw it. Sorry, we have another shooting drawing in AutoCAD. You can auto menu it 30. Okay, 30, and you can click again. Click, now again. Now you can draw it manually. Okay, planar element, concrete type, you can select it 30 or 35, and now the thickness is changed to 30, and click again, click, press escape. And this one we convert it. Now click it all, and opportunity, convert to a planar element. No, we want to keep the line. Okay, you can delete it if you don't want to use it anymore. Okay, now let's change the thickness to 30. Okay, correct. This one is only 25. Okay, now let's check again. Okay, correct. Now let's check for the oval shape and click on opening. Okay, correct. Now this one we have wall. Okay, this one we have wall, so click on it, click on opening. Okay, now complete. If you don't want to use a reference line anymore, you can delete this folder, or you can close the folder if you want to show it anymore. And now let's check for the now you can rotate it. Okay, this one you can rotate it. Should press C and right click, and you can rotate the view. Now you see here your view in the top view. You have to rotate the wall to the vertical. Okay, now clicking on this wall and clicking on the home, and move. You can click copy or move. Now I want to move it. Move by rotation. Click original. You can move one by one, or you can move all. You can move all. You clicking all. Okay, move all, and original. Click the original, and as you can change. Okay, and the angle you can type 90 and preview and see middle key again. Okay, now see here and click on move. Okay, now indicate click work plane on off, and after that you can click on the wireframe and control. Okay, control. If you want to copy, okay, you can copy it, and after that we can copy to another side. Okay, and for this one you have to rotate it. Okay, again rotate it to 90 degree. Now I click on rotate, but the axis we can change the axis. Can change the axis and origin. Now click origin here, and the axis you can change direction. Okay, to this one we want to rotate another 90 degree. You can check. Okay, so put 9 minus 9 degree. Okay, now it correct. Move, and this one we also move it, rotate it, escape, and click on the origin. Okay, again, and press preview, move object, click object. Okay, preview. Okay, positive 90 degree. Okay, it correct. Move. Okay, now you can click on move object, select this object and click move it again, or you can press control and click on the location you want. Now I want to move the object, transition, click on 2 point. Okay, move. Okay, escape again, click the object again, move it again. Okay, move. Okay, now here we have the 4 sideboard and one bottom slab. Okay, if we do not need this wall, you can delete it, and again press control and right click mouse, click and click again. Okay, now see here we complete. You can check for wireframe. Okay, we have over it. In the sec here we have another pie in the location, and the pie in the location, but this wall we do not have pie, so you can click on it, click on alternative, opening, delete opening, click. Okay, now we do not have opening anymore. Okay, let's see it again, and we jump to AutoCAD and to check our model with AutoCAD is correct or not, and it's not correct, we can change. Okay, can change. Okay, now waiting AutoCAD opening. Okay, now let's check. Okay, we have this one is the over it. Okay, over it, this one is for the secure opening. Let's check. Okay, secure opening is correct, but location of it is not correct. Okay, you can change it. Now you can change it by clicking and move again, home, move, rotation again, and origin is this one, and you can rotate 180 degree. Okay, move. After that, move transaction, click on 2 point, 1 2 preview, move. Okay, now save it again, and let's check the AutoCAD. Okay, now it's correct. Now let's check for the wall of the top. Okay, or the top slab, for top slab. So it's 2.56 from the top side. Okay, now let's move it. Click on the axis. Okay, axis, and we view on the elevation, and click the active plan, and after that we have to move it. Now you can move it, can be view. Okay, and you can see, click. Now we can move it to 0 0 to easy to compare. Okay, okay, now again you can click on vector, click this one, and click other one. You see here the vector set is -5, so we have to import 2.56. Now I call it 2.6. Okay, I can round up 2.6 minus 2.6. You can preview. Okay, move it again. Okay, it's correct. Now it's correct for the elevation, because we want to apply the pressure. Okay, auto pressure from the soil and from the water. Now turn off the plan again. We have to check about the local axis and the thickness 25 is 30. This one is 30, correct. This one is 30, correct. See, okay. Okay, it's 25, correct. Okay. Now you have to check for the local axis. Okay. This one local axis is correct. And now local axis on this side is correct. Okay, you can change both the local axis by clicking on object, alternative local axis. Okay, now local axis is the same with the global axis, but it's different in the set is perpendicular with the plane. Okay, the set global axis set local axis set is perpendicular with the plane or element. Okay, now check for this side again and again. Now we can change it. Okay, this side is correct, but we want to correct this side. You set to outside. Okay. Okay. Now it's correct, and we have to check on the bottom. Okay, and at the top. Okay. Okay, now local axis is correct. Okay. You can check for the local axis. You can click on the display, home, display, and family, modeling, plate. Check for the local axis. This one, okay, see here. Now this local axis, these two sides is correct, and two sides is correct. And for the bottom and top is correct, and you can display also for the thickness. Okay, by clicking on the cross section you can display on the cross section. Again, flat annotation, cross section, again, sorry, flat, and you can name signal. Okay, again display, flat, click on annotation, okay, you click on signal, and okay, now you see here about the signal. You can change the text size here. Okay, correct, 25, 30, 30, and top and bottom flap is 30 centimeter. Okay, now after complete modeling, we have to create load. Okay, now click on, you can create load or assign for the soil spring, the soil thickness. Now you can create another soil. Okay, by clicking manage, use soil zone. If you don't have soil zone, you can create new soil zone as soon. Now you can input the signal of the soil layer you get from the site, or you got from the soil tester, and you can input that value. Okay, now let's start. I input it 2.56 is the mat. Okay, is the pit. 2.6 is pit. Okay, you see here is the K-frame. In the Graitec, I use the K-frame for calculate. And add soil. This one I call it clay sauce, and the layer of clay sauce is you can check. Okay, is now we put it 3 meter. Okay, 3 meter. So in the case we use only 2 soil layer. Here you have another soil layer you can input. Okay, you can have pit, clay or pit, or you can input that soil layer. And in the case we use only 2 soil layer. Okay, click on OK. Again, click on the bottom slab, right click, support arm selection, elastic, and you can import or auto. Okay, import, you have to input the value or the thickness, soil thickness in the direction set. The global coordination, you see here the global coordination in the K set. Okay, direction in the direction. Manually you can input it, import. Okay, import value. Now we have to select on the auto value. Okay, auto value, click on OK. And now let's check. Okay, again, soil spring, turn it on, click on there, turn it off again, click on soil spring. You see here the value of soil spring not calculate automatically, indicate. So again, you check on the new soil. Okay, click OK. Now value of the soil spring calculate based on the soil type. You see here indicate we have a weak soil, so the KTZ is only 433 kilonewton per square meter. it is equal to 0.04 mega newton per square meter. Okay, in the case if you have a compact soil at the base, you have sub base, so you can input W. Okay, you can input W by using impulse, or you can input the layer or the gravel or the layer or the the layer or the gravel or stone at the below at the ground slab. Okay, now see here, but in the case we had to input some value for the Kh and Ky for the stability. Now I say it 50 and 50. Okay, after complete, you can create this frame for the wall and for the top and for the bottom, each one. Okay, now escape and press Escape. I call it wall and select all wall, click to the wall, and for this one we call it the Escape again, support, and click on support, turn off support, turn off wall, and Escape again. Top slab or bottom slab, you can now I can top and bottom slab. Okay, click on it, move to the top and bottom. Okay, and for the line you do not need anymore, you can delete it. Okay, click on the, you can press delete key. Yes, I want to delete again, seal it, click on the structure, double click. Okay, now you can show all. Okay, for the core axis, for the thickness, and for the support. Now let's create the load. Create the new, click on the load, and click on the new, click on the line load, and you has another load, you can input it. Okay, you has a seismic, you can input seismic. Now we apply for the load and the line load. In the case we have the load okay, we have the dead load or soil. Okay, we can input the value of soil. We can another dead load from the soil pressure, soil waste at the top, and line load we for the fluid or for the water inside the manhole. We classify the line load. Now we can apply the two load. If you have other supercharge on this area, you can input the supercharge and multiply with the K prime. Okay, when you use the soil data, you can check for the value of the soil soon. Okay, you see here the soil K prime, you can multiply with the K prime. Okay, now click on the deload. We click on the all wall. Okay, you see here all wall. You click on the all wall and right click on the pressure on selection and click on source, and the load case we do not want to generate new load case. If you use this option, load case we will create new. Okay, the load, line load, and create another load. Now we do not want to create new load case. We want to input in the load. Okay, in the load And the pressure, we have internal pressure, internal pressure and internal pressure. Now let's check on the internal pressure and the solution, new solution, and we compare with the reference level. At this level we consider is 0 0, and 0 0 from here is minus 2.6. okay, now take it 0 and press OK. Again, release before indicate it's not correct. It's not correct because we had to correct about the local AC or the panel. You see here local AC inside. Now we want to take local AC in the outside. Okay, so you can click on TNT. Okay, now it's correct. Okay, again click on ball and click right click, load on selection, pressure on selection, and soil. Now we click on internal. So the pressure, the direction of pressure is opposite with the direction of the local assistant. Okay, indicate when we click on the internal and click on the load the load, and the reference level we can take as 0. Okay, take as 0, and we use the solution, new solution, and click on OK. Okay, you see here, and you can select like this one, or you can select by this method. Now Control Z, I turn off support and click it's all. Okay, click it's all, and again right click, load on selection, pressure on selection, soil and internal, click on the deload, and reference level is 0. Okay, is 0. Take the new solution and click on OK. You see here, indicate it's applied for the pressure on wall and the pressure on the top slab. Okay, the pressure on the top slab. Now see it. Now see here, the pressure on the top slab is 47.71 kilonewton. It's the deload of the pit. Okay, you can check with the deload of the pit. You can check my previous tutorial about how to apply a pressure on the solid pressure and liquid pressure on the wall. I verify it manually and with the calculation of the software. Divided with the unit weight of the soil and the top of the slab, multiply with the height of the soil. You can multiply height with density. You can take division it minus 47.71. Okay, now okay, let's complete it for the deload. Okay, now for the light load, you can click on home, light load. Okay, this one for light load, and click on we click on all of the wall and with the base, and right click again, pressure on selection, and now we click on the liquid and direction. Now you can see here the direction is at top here. Okay, at top, this is the bottom. So we do not use the upper level as well because the liquid is has only in the manhole. Okay, not include at the zero level. Okay, now we consider only in the manhole, so pressure in the manhole. So is it the auto detect when you use the correct elevation of the structure. You see liquid density is your liquid density 0.998 ton per cubic meter, and vertical axis is set, and locate we input in the line load, and you can click OK. You can check it is correct or not. Indicate if do not generate a correct pressure, you can change for the direction. Okay, you can change for direction correct directly. This one, like this one, you can click it all and change the direction. Okay, it's correct. And again, now click on all the wall and bottom slab, right click, pressure on selection, click on the liquid, click on ethanol, and line load again. Now you see here for this wall is applied for correct load pressure, and for the bottom is not correct, you can change the direction of load. Okay, again. Now turn on loading. Okay, you see here we have the load, this one. You can click on display, click on the loading area, and click on the intensity and unit. Okay, intensity, district load, and unit load. Okay, you see here this one, the west from the pit. Okay, is minus 747 kilonewton. You can check here 47, and the pressure at the top minus 13, and at the bottom is minus 26. Okay, this one apply for the wall and for the top slab. And for the liquid we apply at the bottom. Okay, this one we apply for the bottom. Now you can turn it off. This one apply at wall, and this one at wall. Okay, and this one for the bottom of the slab. Okay, now correct. After complete for loading, we can check for the element for the wall and for the. Now we check for the strength. Okay, now we want to calculate. Okay, calculate for the concrete, and for the concrete cover we check it. Now it's equal, you can change according to exposure. Now I take it 4.5 centimeter, 4.5, 4.5, 4.5, and 4.5. And we want to calculate about deflection and braking. Okay, okay, it's all. After complete, you can create analysis. Click on analysis. You can create other type analysis if you want. Now click on combination, click simplify. You can change it to the either area. Okay, generate, yes, concrete steel combination. Okay, and click on the envelope you want to create envelope, click on the envelope property, and we click on the force. We want to envelope maximum minimum effort in the planar element. We want to envelope only for the ultimate load. Okay, now see here for the ultimate load. Okay, apply. Okay, after you complete modeling, analysis and design, you can after you complete modeling, apply load, assign support, you can continue to analyze and design. Okay. So here, this is for the 3D view of our structure. Okay, again you can view a wireframe and click on analysis. You can save it and click on analysis, click on OC. See here, warning, area load N02 is superposed with area load N03. Okay, now let's check. Load area N02. Where is load area N02? Okay, this one is superposed with load N03. Where is superposed? One, two. Okay, 2 and 3 is the same, so we have to delete one. It indicates is you the same. Load N02 is superposed with area load N01. Now click N02, delete, come back, it's not superposed. Area load N0 again, run analysis, verify. You see here, warning, area load N02 is superposed with area load N03. Okay, now N02, yeah. Okay, you can delete it. Again, turn on this load and run analysis, verify it again. Okay, now has no other error. Come back and load, click on the load and copy the load, control, click. Okay, now you see here is visual change automatic direction. Okay, now click on save, run analysis again and verify it again. Okay, now it correct, no improposed value. Click on the analysis, click on the OC design. Okay, okay, now complete. And you can change the mask setting if you don't want you like mask setting to analysis. Now you can come back to model, setting. Now we don't want to display about the modeling plate. We do not do want about the show the core axis and the signal. Okay, and now let's check on the Authenticity map preview, and you can check on device show member. Okay, you can check for the map. Okay, you see here the message. You can check for the default. Okay, you can change it. The default value is 1 meter. Now the complete or triangular. And you can correct the message. Now I click on the map option. Now indicate I want to use only 0.3. Okay, 0.3. Okay, now again click on license or see design. You can run. Now again click on the element, click on object authority, and let's see my option. And we want only 0.5. Okay, you can check it to complete. Okay, again analysis or see design. You see here how you can use a different message and method for analysis and design in Graitec Advance Design. Don't worry about cracking limit. Is it the cracking is not include a rebar. It for the concrete section only, not include the rebar. So when you include the rebar, the crack will not appear. Okay, it disappear again. Now click on the force. You can click on the force mask. You can display one locale by one locale. Now I has an envelope. Now click on the force map and click on the HH. Okay, HH is the moment about local axis. Okay, it is the moment about local axis. Now you can display for the local axis. Okay, see here this one about the moment about local axis 8. And you can click on result and the value on diagram. You see here, this is the value. You can customize the value of the moment display here. You can check. Okay, and you can click by one element. Okay, now click only for the top, or you can click for the 3 elements, and you can click on it. You see here only 3 elements. So here this is the moment about local axis. Okay, moment in the direction. See at the middle span is 27.48, and at the spot is 10.57. Okay, now let's check for the bye-bye. And you can display it all to check it. for the load and internal force. Okay, now you can turn it on. Okay, and you can show it. Okay, you can check it. Okay, it moment about local axis H and Y moment about local axis Y, and you can check for H and for Y. Okay, you can check for the C force. Okay, now after complete check internal force, we can check for the rebar. Again, now rebar, this one rebar along axis X in the top in the bottom direction. Okay, now in the bottom direction, you can check here in the case 300 now I check only for the top slab and click it. You see here the value is 384.7 for the bottom in X direction, in this direction. Okay, now we check in the Y direction at the top, 384. Okay, for the bottom. What does it mean for the bottom and top? Now snipping tool, check window, click. Okay, now let me explain you. It is the element, it is the slab, the signature slab. This one the local axis set. Okay, this set, and this one is local axis 8. Okay, now local axis 8. Local axis 8 and local axis 7, and the position is the bottom. Okay, you compare with the local axis is the bottom, and at the position is the top rebar. Moment and C and for it the same when we use for the sign convention in this software is the bottom rebar. Okay, understand? So you look at the local axis. Okay, you look at the local axis, it in here. So when you display in the AYB, so AYB in this direction. Okay, YB and bottom. Okay, at the bottom. Okay, you see here at the bottom, and AHB in this direction at the bottom. Okay, at the bottom at this direction. Okay, at the bottom layer you can check, and this one at the top layer compare with the local axis. Okay, now continue to check for the top again, and select it all and check for it B. Okay, for the YB. Okay, you can check here for the YB, and for the HT at the top layer. Okay, top layer in each direction. Okay, you can check for the all load and outside, and rebar in each direction at the top layer. Okay, you can check here. The maximum is 384. Maybe this view is the minimum rebar in the section. You can verify the minimum rebar in section to compare for this section how much rebar is required for the minimum to prevent cracking appear in the section. Okay, now complete. Thank you for your watching. Thank you. If we have time, we will continue about how to do report to analysis in design in this software. Okay, thank you for your watching. Now we complete for analysis in design manual by using Graitec Advance Design. Thank you.